Hi guys and welcome to this session by Intellipaat. So Kubernetes is a container orchestrating tool which has been adopted by majority of the big players out there, and it's an open source platform. A lot of the companies are now using Kubernetes, and it was developed by Google originally, and they made it open source. So today we have gathered here to answer what is Google Kubernetes engine and have a simple hands-on on it, and have an understanding of what this thing Google Kubernetes engine, or GKE as many people call it, is all about. But before we get into all of that, please subscribe to our channel to never miss an update from Intellipaat. Now let's begin with our agenda. Our agenda today is fourfold. We'll have a brief introduction to Kubernetes in our first section, where we'll talk about what is Kubernetes, what it is used for, and what are the advantages of various different kinds of things like containers and stuff like that. And from there, we'll move on and talk about what is GKE, which is Google Kubernetes Engine, what is it all about, and what is that it does. Apart from that, then we'll move on and talk about few important concepts with respect to Kubernetes or GKE itself, because you need to know some Kubernetes concepts before you use it. And finally, we'll have an hands-on session on GK where we'll try to create pods and services, and we'll create some services and we'll expose it in a notepad fashion, and we'll see how it looks like when we make those changes. We'll get inside pods and containers and have a brief view on what you can do with the help of GKE and Kubernetes. So that is all about the agenda, guys. I hope that is very clear to you. So without wasting any further time, let's just get into the session. So let's begin. So the first topic on the hand is an introduction to Kubernetes. So most of you would be wondering, what is Kubernetes all about? Why is it so famous and stuff like that? But before we get into that, let's hit brief history of time for a while. So if you can see on your screen right now, we have three deployments era here. We have traditional deployment, we have virtualized deployment, and then there is containerized deployment. So initially, people used to use traditional kind of deployment, where you have your physical systems, you have your operating system, and you have your apps, and everything was running on there. But people soon realized that is not very efficient, as you are not able to utilize all of the resources that you have. Some of the apps are crossing the boundaries in terms of resources, because of which other apps are not able to run as efficiently as possible. So people decided that what we can do is we can have something called as an hypervisor, through which you can create virtual machines on top of your operating system. So it will be like having two virtual machines who can have their own independent OS, who have their access to the files, and the app do not have dependencies on each other. So these apps are independent. So if there is no way that I can breach to one app through the other one, which were the case if you were working in the traditional deployment, right? From there, we moved on to something more efficient in the containerized deployment. So people realized that a virtual machine, as good as it is, what it has a huge amount of storage requirements, because a virtual machine also has an OS, and that is a very heavy resource. So you have to install a lot of different things to get it to work, and it will have like GBs of data in it, and still you'll have some problems here and then. So what people wanted was, they wanted an environment where people can work with different things, which is lightweight, and you can run multiple applications on it. So there came containers. So containers are basically you can think of them as lightweight versions of virtual machine. It's very light, and it has whatever the libraries that is required to run your particular application. It is very lightweight. It's like 70-80 MBs, stuff like that. So that's a huge improvement when you look at 1 GB or something. So from there, we move to containerized deployment. So for creating these containers, we use various different kinds of things like Docker and stuff like that. So you can create multiple containers and have apps inside of it that can work. Now let's suppose what you have is an app which is divided into microservices, and you have each container running different kinds of services, and you have like 7-8 containers like that. So how do you go about managing those containers, right? How do you go about doing things with respect to that container? That is when Kubernetes comes into the picture, right? So Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration as well as automation. It does both. Other than that, it has large and very rapidly growing ecosystem, and Kubernetes services support and tools are widely available out there, and they have a very good community which is working out there. And since it is an open source environment, a lot of different people are working on it, and they're producing new things which make it more efficient, more usable, much more easier to interact with, more intuitive and stuff like that, right? So moving along, let's talk about few of the features of Kubernetes. Like, what else is there that Kubernetes provides that so many people are using Kubernetes as their container orchestration tool? So Kubernetes is one of the most popular platforms out there. So it basically gives you this service discovery and load balancing. It gives you storage orchestration, automated rollouts and rollbacks, automatic bin packing, self-healing, and secret management and configuration. So let's dive into all of these and look at all of these one by one so that we have a better understanding of what it is that Kubernetes is providing to us. So let's start with the service discovery and load balancing. So Kubernetes can expose their containers using DNS name or using their own IP address. They can do it with respect to that, and its traffic to containers is high. So if the traffic to the containers is, let's say, very high, then Kubernetes is able to load balance and distribute the network traffic so that the deployment is stable. Now it does that in a very particular fashion where you have to understand the architecture. So if you're not familiar with the architecture, we at Intellipaat have created another Kubernetes introduction video where you can learn about the Kubernetes architecture, what is YAML files and stuff like that. We will not get into the depth of it in this session. So if you wanted to learn about the Kubernetes architecture and stuff like that, please do refer to that session so that you understand how it is doing these things, right? Moving along, we have storage orchestration. Kubernetes allows you to mount storage system of your own choice, such as local storage, public cloud providers, and more. Apart from that, it gives you various different kinds of storage options as well. So you have EMTDIR kind of an option where you have storage which will be there till your pod lives, and once your pod dies, it will not be there. So you have something called as a persistent volume also. So even if your pods get deleted due to some reason or the other, and since Kubernetes has this feature of self-healing where it automatically respawns if a pod is deleted and stuff like that, so when it respawns the new pod, the data from your old pod will be saved if you are using the particular persistent volume mounts, right? So that is something very good that Kubernetes provides. Moving ahead, we have automated rollout and rollback. So you can describe the state of your deployed containers using Kubernetes, and it can change the actual state to the desired state. So let's say we have something called as pods. So pods can be thought as the most lowest form of the execution unit in Kubernetes. So you have various different pods which can have various different containers which do a lot of different things, right? So inside of these pods, let's say I maintain like 3 replicas of one particular pod that I'm creating, like one particular kind of service which I've written 3 different kinds of replica for it. So let's say if requirement for those pods is very high and huge traffic is there, and you want to roll it to from 3 replicas to 4, you can easily do that with the help of Kubernetes, and you can roll it back down as well. Other than that, Kubernetes also provides you with this amazing feature where, let's say I have 10 pods, right? 10 pods which are working for my particular service. Now let's say I'm moving my image version which I have for those pods from, let's say, 1.0 to 2.0. So while creating that, there are 2 ways to go about it. Either you take all of your pods down and then upload all of your new pods, and this brings a downtime to the system which is not desirable at all. So what you can go about doing is you can do automated rolling update, where you can what Kubernetes will do is it will take down one pod of the older version and it will bring out the one new pod, and it will keep on doing that till it replaces all of the pods which are the older version to the newer version. It will keep on doing that, and that's how it basically helps you maintain your application without going through a downtime and going through an update without having some kind of a downtime. So that is an advantage, another advantage that Kubernetes provides. Other than that, it gives you automatic bin packing, which is basically you provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You can tell Kubernetes how much CPU and memory and of these kinds is required, and Kubernetes can fit containers onto your nodes and make the best use of these resources, right? So that is something else that Kubernetes provides, which is very desirable. Moving along, we have the self-healing capability, which is very desirable for any company who wants to run seamless services, which do not want their service to be having a downtime. So what Kubernetes does is, let's say I've mentioned this before, we have 4 pods and one of the containers gets killed, or one of the post pods get killed due to some reason, and what Kubernetes does it is automatically restarts the containers if it fails, if it replaces the containers basically, so that you have more healthier pods which are in working condition who respond, so that your clients do not see any kind of a downtime with respect to your service. Moving along, there is another thing called as secrets and configuration. So Kubernetes basically helps you store sensitive information such as passwords, authentication tokens, SSH keys, and stuff like that. So you can deploy and update secrets and application configuration without rebuilding your container images. Now, without exposing your secrets in configuration. You can have a kind of a storage. It's called it secret mounts also, at sometimes it's sometimes considered as a storage unit as well. So you can have encrypted form of data pass which can be passed from here and there, so that you do not expose your let's say one particular kind of password or stuff like that, right? So let's move along. So what is GKE, right? So what is this Google Kubernetes engine? So Kubernetes was something which was created for container orchestration and what's being used offline on premise with many people. So what people decided was, since the boom of the cloud era, we have AWS, Azure, and stuff like that. So all of these cloud platforms, like Google Cloud Platform itself, every cloud platform has now started providing their own Google Kubernetes service, so that it's much easier for you to go about doing things. Like Amazon has EKS, which is Elastic Kubernetes Services. Google Cloud Platform provides you with Google Kubernetes Engine, which is basically a Kubernetes service which you can use to create and deploy clusters on Kubernetes and do a lot of different things with it. You have graphs and stuff like that related to it. So let's have a look on it. So Google Kubernetes Engine, also known as GKE, is a cluster manager and orchestration system for running Docker containers in the cloud. Right? It is a production ready environment with guaranteed uptime, load balancing, and it includes container networking features as well. It allows you to create multiple node clusters while also providing Kubernetes features which are self-healing and what all we just saw. It provides you with all of that. So GKE does that. So if you go to the Google Cloud Platform and search for Kubernetes engine, and this is what basically your screen would look like when you are looking at a Kubernetes engine. So you can see things that you should know is what is a cluster, what are different workloads, what is service and ingress. You should know what is a deployment, you should know what is a pod, what is a container, how different things work again, and what is storage and what is the configuration. So if you have doubts with respect to these, I'd recommend you to watch our previous video on Kubernetes, where we discussed about all of these concepts in detail with respect to architecture and YAML files and pods and deployments and stuff like that. We'll talk about a little bit about pods and deployments and containers right now as well, so that we have a clear picture before we get into the hands-on session. But it's more desirable that you learn the concepts so that you can understand what is going on in the hands-on session as well. So let's discuss some of the important Kubernetes concepts. So you need to know a few of these because we'll be doing that in the hands-on. So you must know what we are going to do and how is it working. Let's quickly talk about some of these important concepts. So we'll start with the pod. So a pod is a basic execution unit of the Kubernetes application. It is the smallest and the simplest unit in Kubernetes object model that you can create or deploy. A pod represents a running processes running on your particular cluster. It basically represents the running processes which are there on your cluster. So basically the architecture is like that you have one master node through which you have multiple slave nodes created. In your master node you will have your kubectl deployed, which is your command line interface, which will interact, and through etcd and other architectural stuff, it basically interacts and maintains whatever the desirable state you define with respect to all of your pods, deployments, and services. It does that through that. So it has its own configuration mapping, and internal it generally communicates through internal APIs and internal IP addresses which are not exposed outside. So if you have, let's say, any particular pod, it will not be exposed outside unless and until you explicitly create an external pathway to your pod, right? So your pod basically will have a few containers which will have different things running inside of them. You'll understand that more when we get into the hands-on session. So your pods can spawn on any particular given node at any point of time when you create a pod, unless and until you have decided some taints and tolerations to your particular cluster. A taints and toleration, what it basically does is, let's say one of those, through my master I have connected 4 nodes. Like one of those nodes which I have is a CPU where we have GPU configuration. Now it is more desirable that any tasks which require GPU configuration, let's say if we have some image processing tasks which are there in one particular container, then it is more desirable that all of those tasks should go to this particular node, right? So what you do is you try to attach those pods to those nodes which will have this particular configuration, and you can do that through taints and toleration, right? So there are different kinds of pods as well. There is init pods which are initialized pre-hand, and there are normal kinds of pods and stuff like that. So that is something you should know about pods. Other things that pods are used for is basically pods can be used to manage your content files, data loaders, cache managers, and stuff like that. It keeps a log and checkpoints, backs up, does compression, rotation, and snapshotting, etc. of different details which are there inside of your log. It watches the data change. It creates a log trail. It does event publishing and stuff like that. It has proxies, bridges, adapters, controllers, managers, configurations, updaters, and a lot of different things are there. So you can think of your pods as somewhere you can store your data. So in my pods, I can have a container, and in that container, I can have an HTML file which I can use to run different applications on websites, stuff like that. We'll do something similar to that in our hands-on session. So that is something you can think of pods like. So moving along, we have something called as a deployment round. With Kubernetes, it is very much expected that you will have multiple replications of the similar pod. So let's say one of my pods does image processing, right? I have putting the files of image processing. So what you want is when you're running a website or something like that, you will have a multiple number of service requests which are coming to your one particular pod. Now, a pod can only service so many requests at one time, right? So it won't be able to do it. So what people do is they create multiple replicas so that there is no downtime. So let's say I have 5 replicas. Now, these 5 replicas need to be maintained at all times. Now, these can be done either with the help of a replication controller, which is something which people use a lot. So replication controller's job is basically to create replicas of the replica sets of the pods. You can do that, or you can go for deployments. Deployments are basically an upgraded and higher version of the replication controller. They manage the deployment of the replica sets, which is also an upgraded version of replication controller. Now, they have the capability to update the replica sets. They are also capable of rolling back to the previous version. So as I mentioned before, with respect to the pods, you can go about updating different versions with the help of deployments. You can have rolling updates with respect to deployment, or you can roll back to the previous version using deployments as well, right? So let's move along. So deployment provides many updated features. Like it has a lot of different things that your replication controller does not. And in Kubernetes master, the deployment controller basically makes it happen, makes all of the things happen, and it has the capability to change the deployment midway as well. So you can change the deployment midway as well, and you have something called as selectors and match labels to call application and stuff like that. So there is another, again, if you have to clarify all of these concepts, you have to visit that video. Talking about services, so as I mentioned before, so your pods, they have Kubernetes has an internal infrastructure where it communicates internally. So you do not have you have like a network proxy where if they communicate with each other, you do not know how they communicate, through which pipeline that so through which network communication that they are communicating. If you are looking from the outside, nobody can reach to my cluster unless I expose it. So there is 2 ways that you can go about exposing these clusters. So one is called as a service. A service is a defined set of logical pods. You can think of service as a set of logical pods that it does not show you where the actual pod is. It helps you interact with the pod without telling you where the pod is. So let's think of a gate where if you go to that gate and you tell them ki I want to reach this particular destination, and the gate directly puts you on that destination. You do not know how you reach there, but it is basically helping you communicate with them. So it is giving you whatever you needed from that destination to your particular place, so you do not have to worry about it. It feels like you are communicating to the pod itself, but it goes through one particular kind of a gateway kind of thing, right? You can think of it like that. So it can be defined as an abstraction on top of the pods, which provides single IP address DNS name by which pods can be accessed, right? With service, it is very easy to manage load balancing configuration, and it helps to scale the pods very easily. Now there are different kinds of services as well. So you have a cluster IP kind of service, which is not externally reachable. You have a load balancer type of service, you have an external namespace service, and you have a node port kind of service. Now if you want to expose your ports externally, then you have to create the services of the type node port. It basically helps you expose your services. The other way to go about exposing your pods is creating an ingress. Now ingress basically it does a similar thing. It creates an external host for your particular application. It will create a pathway for you. So you can think of ingress as something which is on top of a service as well. So ingress is much better than services when it comes to exposing a pod. Again, if you have doubts, you can just refer that video and you'll get it clarified. Moving along, service is a REST object in Kubernetes whose definition can be posted to Kubernetes API server on Kubernetes master to create a new instance. The set of pods which are targeted by a service is usually determined by a selector. So when we talk about the YAML files, you will see that there is a field called as selectors, which basically helps you choose one particular application from the other. So let's say we have various different kinds of applications. I have 5 applications, but those applications I can call them through their selectors. Selectors can be thought of as simple as name, as through you're calling through them some kind of a name. So that is something that you can do. Right, we'll see example of that when we get into the hands-on session just now. So to create a specification for an object named my service, that which targets the TCP port 9366 on any pod with the app name is which is my app, you basically need to define a service which looks like the one on your screen. So this is what a service Camel file looks like. So you have defined the API version and you have defined the kind. So if it was a deployment, I would have written deployment in there. If it was a pod, I would have written pod in there. Since we are defining a service, the kind of the kind will be specified as service. Apart from that, we have a metadata, which is the name. And as you can see here, there is a spec, and spec inside of spec you have a selector, and in that selector we have called it is as my app. So if I want to call this service, I have to use the selector my app only, and through that I can call this service very easily. Other than that, we have given it the target ports and stuff like that. So whatever the target port is, and we can define where you want to expose it and stuff like that. So you have a target port for that, right? So let's quickly jump on and look at the GKE service itself and understand these concepts on a fairly hands-on level so that we can do better things with it. So let's quickly jump on there, and then we'll see what we can do. So once you open your Google Cloud platform, this is how it will look like. It will show you the CPU usage, if you have used any APIs that you have called and stuff like that. All of the resources, instances that you have created, trace within the last 7 days, news, error reportings, and everything which is with respect to that. It will show you everything here. You can go to the navigation menu and see the various different things with respect to the cloud platform. But what we are interested in is Kubernetes engine, so we'll search for that. So here it is. We'll just click on that. So we have one pre-made cluster which did not close properly, so that's why the option of deleting it is not here. Anyways, we'll go on and create a new cluster and just work on it and see how it looks like. So this is what your Kubernetes GKE engine looks like. Here you have the workloads, you have the services and ingress. So we have no workloads created as of yet. We have no such services created, we have no application, no configuration, no storage whatsoever. So you will not find a lot of things. You can free navigate from this place itself. So we'll come here to the clusters itself, and we'll try to refresh it once, and we'll create a new cluster. So all you have to do is to click at the new cluster. You can name your cluster whatever you want. We'll name it as cluster 2, and you can have it zonal or regional. You can choose the zone wherever you want this cluster to be, and these are all the zones which are available to you. I'm going to keep it as default. We will not change those locations. You can specify the default node locations as well if you want to, but we are not looking to change that. You can change the release version and you can choose whatever of these. And once you are done with all of this, all you have to do is click the create button right here. So let's quickly click that. So it will submit and take a couple of seconds to initialize your cluster. As you can see, our old cluster has finally disappeared and a new cluster is being created, and we'll just wait for the cluster to start. That should take about a couple of seconds, and we have to wait till our cluster is initialized before we go ahead and do something with it. So let's wait for it. Apart from this, like if you had some other cloud services, you can use similar way. And if you're using, let's say, an EC2 instance or using on Linux, you have to install Kubernetes services. But these platforms come with Kubernetes pre-installed, where you can create your plus clusters. Pre-made clusters will be created for you, and you can customize them according to your needs. And it should take about a couple of seconds to get initialized, and we'll just wait for it to work real quickly, and then we'll begin soon. So as you can see, finally our cluster has been created. Our cluster size is 3. We have 3 CPUs and 11.25 total GBs of memory data. And we have the clusters here. What we have to do here is we have to click on connect. As you can see, you have to run this in shell command line. So we'll be using the shell command line for our purpose only, for using Kubernetes as well. So we'll just quickly click on this. So it will open a shell on the bottom of your screen right here, and it will provision your cloud shell to your machine. So we'll just wait for that to happen. Once it is done, that all you have to do is press enter to connect your shell to that, and I think it's ready. Let's check. So let's do kubectl get nodes to find out if we have a working Kubernetes cluster. It's taking a couple of seconds. It's not initialized yet. The cluster 2 is still creating. Okay. So now our cluster has been initialized. So let's check if the cluster is ready. kubectl get nodes, and you can see ready state. We have it in the ready state. So our Kubernetes cluster has been created. Now let us begin with the small different things. So let's do kubectl get pods. So we should not have any pods as of now. So we do not have it yet. Kubectl get pods. My bad. And as you can see, no pods have been created in the default namespace. So what we'll be doing is we'll be defining this particular YAML file. So if you are familiar with creating YAML file, this is a kind of a deployment. We have to define a deployment in this section where the version is apps v1. We have defined the kind as deployment. The metadata is nginx. So this, we are creating an nginx deployment which has about 3 replicas in it. And we'll change the number of replicas to, for now, let's say 1 for now, so that we only create one pod, and we can change it later on. And we have other service also which is defined, so you can define all of that in one particular YAML file so that you don't have to run a YAML file again and again and again. So as you can see, this is a service which is of the type node port, and it is looking for the port number which is 80. So the target port for this service is 80. So this is basically doing that for us. So what we have the type as load balancer. Sorry, it's not node port, it is of the type load balancer. And so you can see here. So let's just quickly copy this YAML file real quickly and see what happens. So in order to do that, what you have to do is you have to create a file here. So let's call it nano test1.yaml. In this YAML file, okay, we already have a YAML defined in this one, so we will exit from here, and nano, we'll create another YAML file which is not of this kind. So let's call it gktest.yaml. You can see this is a new one, and we'll paste our particular file here. So we have copied everything from top to bottom, and all you have to do is save the file here. And once you have done that, you have to create this file. So whatever is in the file which we have defined, that is the deployment as well as the service, will get created. So command for that is kubectl create -f gktest.yaml, right? It'll take a couple of seconds. So as you can see, the deployment for the apps nginx is created, the service of the types of nginx is created. So if you want to check what all pods we have now, so let's do kubectl get pods. We have one nginx pod running, and you can check the similar for the services as well. kubectl get deployments or get services, get svc. Let's do it. Let's see how it is. And this is our service. So see, you can see the service type is load balancer here, and it is just pending. It has not been provisioned yet. So it's still in pending state. So we have to wait for it to actually run, so that we can go about making a few changes to it. And that is about that. So let's quickly, what we can do till the point being that now is we can get inside the nginx, and we can what nginx does is, when we can export this nginx page, it displays an html page. We can edit that html page to display our own code and see how it works, right? So let's check again if our service has been initialized, and you can see the nginx load balancer service has been initialized now, and it's on the external IP has been mentioned, and wherever it is, it's everything has been mentioned. So the next thing that we have to do is we have to get inside the pods, right? We need to change those particular thing. So let's get the pod that we want to get inside. Get pods. So if I want to get inside of this pod and see what all is in there, so I have to use the command which is called exec. So we have to do kubectl exec -it space the pod that you want to get inside of, right here, and then -- space /bin/bash. This is the command to get inside of the pod. Take a couple of seconds. As you can see, the Power BI has changed to root engine X. So we are inside of this pod now, the pod that we defined. We are inside the pod now. So let's see what all things are there inside of this pod. So the command for that is ls. So you can see a lot of different things is there. So I know what is the path to the nginx YAML file. So we have to get inside the user. So just like any other thing, we have to do cd user, then do ls again and see what all components are in here. I know it is inside of share, so you can do cd share, and in there we have to check what all is there in share. You can see a lot of different things is there, but I know that the file is inside of this folder called as nginx. So I'll go to nginx. In there, now what I have to do is check for ls again, and you can see there is a folder called as html. So we'll go to cd html and ls. So we can see there is two files. One is 50x.html and the other one is index.html. So what we have to do is we have to edit the index.html, that is the page which is generally displayed on the outside world, right? If you want, we can check it real quickly. We had a kubectl service defined at the external port somewhere, right? So this, if I go to this, it should generally represent the html ports. Sorry, it should show me the HTML screen. Welcome to Nginx. We are trying to move this page to whatever we wanted to create for this service. So that's why we are inside of this. So let's quickly look at what this how we can change that. So the command to change whatever inside the file is cat this arrow, then file name, which is index.html. And now you have to copy or paste the code that you want. So I have created a code right here which I want for my index.html. I will quickly copy that, and then I will go back to my page. Here I will paste all of the code, and the command to exit it with saving is Control D. So once I do that, it should register whatever the changes have been made. So if we are outside of the file now. Now what we have to do is we have to exit the root, because we cannot run the commands here. We have to go to the command line interface, which is the kubectl commands won't work inside of here. We have to go outside, so we have to do Control D again. As you can see, we are back to our Power BI. Now what I have to do is just check if my service is still running. So kubectl get svc. So in here we still have the external IP which is working, and we'll just copy this real quickly and see if that changes things. So still not. So finally the change has been made on the same IP address which we copied. As you can see, 124 right here. So now welcome to GKE test. This was created by Intellipaat. So we changed this. So this is how you basically use a pod. You could have a lot of different things inside of the pod. As we saw right here, we went inside the pod. We made a few changes to things here and there. And then inside of that, I changed the page where we were putting our code to, and we created it. So this is hosting my one particular service. It is not directly going to the pod. It is going through my service, and it is basically mapping it. So that is how you can basically use GCP platform, and that is how you can use Kubernetes. You can do various different things with it. You can delete these services and do a lot of different things. So let's try to delete something. Delete pod, or we can delete the file itself. If I want to delete, let's say I've created with that file, right? So if I wanted to delete two of the deployment, and the service together, all I have to do is delete the file. Delete -f. Then what was my services file's name? My file's name was gk test something, right? The file which we used, gktest.yaml. So gktest.yaml, and you can see my deployments and my services have been created. So if I try to do it again, my host should return that there is nothing of that sort there. There is nothing there, because there is no such thing present anymore. You can just copy the external IP, paste it here. It will not work for you because there is nothing there anymore, because we deleted the services. So we've deleted it right now. So other thing that you can do with it is probably let's create that service again, and let's go back and let's create so we can see for right now we are not seeing anything about the services and like that. It's saying you to learn more, and same goes for the ingress. And if you go for the storage also, you have not defined any persistent volume, or it shows only the storage classes which have been predefined. So you can define storage classes and you can manage them from here. So I'll show you how that works. So let's quickly clear this. Okay, so what we'll do is we'll create our services again, which was the gk test.yaml. This will create my deployment as well as my service, right? So my deployments and my services has been created. So now if I refresh this, I should see my services here. So you can see it is creating the service endpoints. It is of the type load balancer, and it is showing me different things with respect to that. So once it gets ready, so we can check it from here also, kubectl, my bad, kubectl get svc. So now we can see it is still in pending state. So we have to wait for a couple of seconds for the pending state to get over. So if we go to the services right now, we can see various different things with respect to this service. You can see it's ready now. So we can see various things related to this service, like what is the namespace it is in. Since it is, we have designed it, we have not defined any particular namespace. It is in the default namespace. It is showing the labels and load balancer external endpoints. Where is it? And what is the status of the deployment serving pods? What are the pods inside of this? You can get inside of these pods as well. In here, you can find the details with respect to the pods, what it has requested, and how the things have been so far. And you can check things from here as well. On your command line, you can check for kubectl describe pods, and you need the pod name for that. So you can get that pod name from here itself, I think. Yeah, the pod name, we'll copy it and we'll paste it here. You can see various different things with respect to this pod has all of the different commands that you can execute through here. You can see what is the start time, the label, the annotations which is being used, what is the status, and what are the different things that it has. And you can change various things regarding that, and you can check from the services here as well. You can if you define more services, you will see more endpoints in here, and similarly if you define an ingress, it will come in here. If we define a storage class, then we can have those storage classes in here, and we can segregate them on various standards, like what is the provisioner, what is the type of the cluster, what zone it is, and what cluster does that volume serve to. So we can check from all of the things that is here. So it is very intuitive in terms of that. And similarly, if we are looking at the workload right now, so we have one deployment which has one pod, and we can see everything it is here and here. So in here we can check the various different things with respect to our particular default the deployment details which we have in here. You can see what is the active revision and different things which is there with respect to that. And if you want to check how self-healing perspective of the Kubernetes, what you can do is uh, kubectl get pods. I need the name of my pod. That is the name of my pod. What if I delete that pod? So what will happen to the deployment? The deployment's job is to keep on creating new pods, right? So if I do delete pods and then provide the pod name, which is this, it will delete this particular pod. Now, if the job of the deployment was to self-heal, right? I deleted a pod, but the configuration says that I should always have one replica. So in that scenario, what it should have done is it should have remade the pod. So the pod will have a new name now, as you can see. It is different from that one, but it's the job of the particular deployment to make your replica sets be available at all points of time. If I had two replicas here, I will see two pods at all times. Even if I delete one, or if one gets deleted or restarted for some other reason, you can see that with the help of this. And you can auto scale from here. You can auto scale, as you can see. You can change the minimum replicas to, let's say, 2. Now if I do that and I auto scale, once it gets deployed, I should have two particular copies of these, right? It should have two different replicas which should be there. You can see there are two pods now. Since we auto scaled it from our Kubernetes engine, since we auto scaled it from our Kubernetes engine, to auto scale, it automatically went to 2. And you can change that. You can have more actions with respect to it, and you can do auto update and different actions as well. You can do all of these. You can auto scale, you can do rolling update, you can scale, you can expose, you can do a lot of different things. With the help of that, it will automatically do for you. That is the advantage of having of that. Or you can get YAML or edit YAML. You can make some changes from there itself. You can see what the memory standard is. It's using 2.1 MBs so far, and various different status. Now I have two managed pods, and here you can see it has uploaded, and there are zero restarts still now. So that is how you can use that. And with respect to services also, you can edit the services for some if there is some YAML that you want to edit and I want to change something from in here, I can make those changes directly to my particular YAML. Or we can create an like we can go through a kubectl as well, and we can do it from there as well. And what other feature are we seeing right now is we can do port forwarding as well with respect to that. So whatever the port forwarding is, you can run it in the shell and make some changes with respect to that. And this is the external endpoint of the particular service which we've created of the type load balancer. You can see the graphs being plotted, and you can measure it for various different number of hours, like 1 hour, 6 hours, and whatever it is. You can have that detailed version of it also, and you can have various different events that have occurred, like the scaling of the pods was done, like we auto scale the pods. So you can see the successful rescale was done to 2 pods, and we change that replication as well. So you can do that also with the help of this platform. So that is the easy things that this platform provides. You can see the various things from the info panel. You can get what is meant by all of these steps, so you can learn more about it intuitively with the help of this platform, which is the Kubernetes engine. And that is about it, guys. So that is how you basically use. You can define various different things. You can manage it from here. You can scale and downscale and do various different things with it. And similarly, you can create a lot of different storage classes and have configurations of the secret, which is the default token, and you can manage various different configurations also from here itself. So that is the great thing that Kubernetes provides. So it gives the command line interface an intuitive end where you can use and see how your different things are doing. You can create graphs and stuff, and this service does everything for you, the Kubernetes engine service in the cloud platform. So that is about it, guys. You can see various different things. You can refresh and create a cluster of your own, and you can try doing different experiments with it. You can create your own images. You can check the deployments and stuff like that. So that is basically how you use Google Kubernetes engine. We come to the end of this session. So if you have any doubts with respect to this session, you can leave a comment down below. And if you are confused about your own career and you do not know which certifications to go for, or if you want to enroll to any of our Kubernetes certifications or DevOps certifications and stuff like that, the numbers are on your screen. These are toll-free numbers. You can talk to our course advisors who will guide you along with your resume to tell you what kinds of certification is suited for you to land a better job tomorrow. So with that, guys, I would like to end this session. Thank you so much for watching, and I'll see you in the next one.